Okay, so I'm making a video to kind of try and explain my solar setup. So these panels here, they're in 2 series, 2 parallel, this group of 4. There's some cheap Amazon branch connectors back there. And basically, let me show you. This is what we have. These are just the cheap branch connectors. If I move the other panel, you can see the other one. So that's what we're using. And let's go into this wire over here, and it meets up with this. So, but before we get to that, these ones here are also hooked up with the same cheap branch connectors, and there's actually an extension here so that they'll reach 10 gauge. Everything's 10 gauge. I don't know about the branch connectors. I think they use different sizes. So we've got the ones behind me, 2 series, 2 parallel, and the 2 series, 3 parallel, and they're coming over here. So I did have a problem. This is what got me started here. I did have a problem, and I melted something. These are going on their own run all by themselves, all 6 of them. So the 6 is going right here. So where it gets a little complicated is I've got these 2 series, 2 parallel over here. Okay, so they're coming in here, and originally I had everything going in through here, and it melted the MC4 connector here, so I cut it off, and I just put this on here for temporary because I need to get another branch. So this wire in here go and feed. So you have basically, in this case, 2 series, 4 parallel, I guess. But what I'm trying to explain here is that there's parallels upon parallels, and so obviously this is a hazard point right here. And with cheap MC4 connectors, and then running hot and then melting, then we have a problem. So probably none of this is even remotely safe. So these 2 runs go in here. I have another set of panels that you can't see from here, and then in here, don't mind my mess, we have 2 groups of 10 gauge going into this 63 amp circuit breaker going into my charge controller. There's another, the other unfused, uncircuit breakered group is actually, I made a mistake, it's actually 2 series, 3 parallel. I put it down that it was just 4 panels, but it's actually 6. So I forced them inside of here. They weren't really that hard to get because the smaller group that doesn't have a circuit breaker is actually using, I think this is 12 gauge primary wire. And it only gets sun when the sun is setting, so it's usually not doing anything. You're going to wonder what this green and black wire is here. It goes to a capacitor here that connects to the ground to kind of filter the input. So this guy is just sitting here taking all these panels, and that's what I've got it set on. So I don't ever see over 2,000 watts, even when I put it under a real serious load. Right now, let's see, we're not even on right now, but we've had solar storms. I keep thinking of ham radio, solar storms. We keep having thunderstorms. So right now I'm 66 volts coming in here, and I'm putting out 60 watts. I'll flip it on, and it'll take a minute, but the air conditioner will put like a 500 or 600 watt load on it, and then there's a second air conditioner that I run sometimes on it that's 1,000 watts. So, at any rate, I've never seen it go over like 2.1 kW on the input side. So, but I know there's extremely close to the limit of this circuit breaker. So what I want to do is I want to get all this stuff no longer experimental, get it to where it's safe, where I don't have to turn and disconnect everything off when I'm not monitoring it.